Multi-agent AI systems are incredibly powerful. They can plan, coordinate, execute complex workflows, but they may not always be reliable. Frameworks like AutoGen and LangGraph in particular unlocked multi-agent collaboration, but they lack something foundational: guarantees. The example here is intentionally simple. A travel agent books a flight, the flight is cancelled, and the system forgets to cancel the hotel. Nothing intelligent went wrong, and that's the state of multi-agent AI today. This paper identifies three root causes. First, unreliable self-validation. LLMs struggle to verify their own reasoning. Second, context amnesia. Over long workflows, agents forget early constraints due to limited context windows. And a third limitation is no transactional safeguards. Once something goes wrong, there's no clean way to roll back. This paper proposes SagaLLM, which treats multi-agent collaboration like a distributed system. SagaLLM integrates the classic Saga transaction paradigm from distributed systems like microservices into LLM-based agents. Every step is validated, every action is logged, and if something fails, the system recovers gracefully. SagaLLM is built on three pillars: transactional integrity, where workflows move through consistent states with rollbacks and compensations; independent validation, a global validation agent checks outputs externally, not trusting agents to self-police; and persistent context management. Critical goals and constraints live outside the token window. Together, these eliminate the most common failure modes. The authors test SagaLLM using real-world planning problems from the Realm benchmark. These tasks in the benchmark aren't static. They include unexpected disruptions, exactly where standard agents tend to fail. Here's what happens with a standard LLM in this example. A delayed flight triggers replanning, but the model loses track of earlier constraints. The oven is left unattended, travel time is miscalculated, dinner misses its deadline. The system tries to fix everything and breaks more things in the process. SagaLLM handles the same disruption very differently. It detects failure, rolls back to the last valid state, preserves immutable constraints like fire safety and deadlines, and generates compensatory actions, not a full rewrite. Dinner is still on time, consistency is maintained. This other slide highlights a subtle but critical failure mode. A traffic alert causes a standard agent to rewrite the past, retasking someone to drive to the airport even though they already arrived. Now, SagaLLM forbids this. Executed actions are immutable. As simple as that. This actually is my most favorite AI agent paper for this year. SagaLLM is inspired by decades of distributed systems research, particularly Saga transactions. The lesson, turns out, is timeless and looks like is what is going to get our AI agents into production finally. Hey, check out the paper in the description below, and thank you for watching.